Hello and welcome once again to Principles of Reinforced Concrete, and in today's video, we would be discussing about a sample problem of a column under biaxial bending. So when we say biaxial bending, so this is to be bending, or this is to be a case wherein it is to be bending into axes. So unlike in our last example, natin, this is just to be under uniaxial bending because it is only bending about one axis. So ayon, in this case, if this is now to be your eccentricity, it is now only bending about the y-axis. So if this is to be your y-axis, so yung bending niya is to be like this. So it is only bending in one axis. But what about for this particular example, lagyan ngayon natin siya ng eccentricity y, so EY. So with that guys, so ito na ngayon yung EY natin. So ito siya guys, no, ito yung dati niyang eccentricity. So same lang siya, pero ngayon dinagdagan ko siya ngayon ng eccentricity along the y direction. So ngayon ito na yung eccentricity y niya. And thus it will now bend on two axes. So it will now bend at the x-axis and it will bend about the y-axis. So nakita nyo, dalawang bending na siya. So with that, this is now what we would be calling our biaxial bending. Okay, so how can we solve for these kinds of problems? So sa totoo lang, napakadali nito. So we would just be making use of this particular formula. So this is what we would be calling our load contour method, or this formula. So this is now what we would be calling our Bressler's reciprocal load equation. So ito, reciprocal method ang tawag dito. So you do not need to solve for the two equations, pero kung gusto nyo, pwede din. Pero kung hindi, pwedeng mamili na lang kayo. So this is to be a snippet from the book of Arthur Nilsson. So nanggaling to sa page 300 ng libro ni Arthur Nilsson. Ito naman sa page 298. Okay, so let me explain this equation here first. So ito kasi yung mas madali. So 1 over Pn. So whereas your Pn is to be the approximate value of the nominal load in biaxial bending, so it means that that is to be the Pn. So ito yung Pn or yung strength mismo ng system natin. So ayun ito yung sinasolve natin actually. So what is now to be your Pnxo, your Pnyo, and your Po? So your Pnxo is to be the nominal load when only eccentricity y is present. So in other words, ito yung uniaxial bending stress niya. Uniaxial bending nominal force niya or nominal load. And ito naman PNYO, ganun din. It's just that only EX is present. So aalisin nyo yung EY and yung EX respectively for you to get the values of your PNYO and PNXO. And as for your PO, this is to be the nominal load for concentrically loaded columns. Alam nyo na din kung paano isolve yan. So napakadali yan. No? So PO is to be equal to 0.85 FC prime times AG minus AST plus Fy times AST. So alam nyo na to actually guys. So ayun. Okay, so for your value for your PNYO and PNXO, napakadali niyan. And napakadali niyan if gagamit kayo ng interaction diagram, and kapag gagamit kayo ng analytic, mas accurate yung answer nyo pero medyo mas matrabaho siya. So in our example for today, let us just use the interaction diagram. Okay, so ulitin ko lang. I-copy ko tong equation na to dun sa pinakaunang slide, no? So 1 divided by Pn is to be equal to 1 divided by Pnxo plus 1 divided by Pnyo minus 1 divided by Po. So, ano ba yung mga kailangan natin isolve dito? So, isolve natin itong tatlo para masolve natin yung Pn ng biaxial. Okay, so for our Pnxo, so going back here, it is said here that your Pnxo is to be the nominal load when only eccentricity Ey is present, and Pnxo is to be the nominal load when only eccentricity Ex is present. So ngayon, solve muna natin itong PNYO. So yung PNYO daw is yung Pn, yun daw yung Pn natin if wala yung eccentricity Y. So basically guys, since di ko naman talaga binago to problem, nasolve ko na to before. So nasolve ko na yan. So ito actually yan sa previous video, 3585.4. So ito gumamit kasi ako ng interaction diagram before. So I would just be copying this. And basically, this is already our PNYO. So, lagay ko na lang dito. PNYO. So, paano ba natin sinolve yung PNYO na yan dati? So, ginamit natin tong interaction diagram na to. Sinolve natin yung rho G. So, we have solved for rho G. We have solved for, ano ba to? Sigma ba to? Gamma pala. We have solved for gamma. Then, we have solved for E over H. Then, using this interaction diagram, ito yung nakita nating value niya. So, ito yung nakita nating intersection. Then, yung value niya, 0.5. Then, using this equation, we have solved for Pn already. So, 0.5 is equal to Pn divided by Fc prime times Eg. Then, solving for that, yung Pn na natin is to be ito, 3585.4. Okay, but what about for Pnxo? So, ito hindi pa natin nasa-solve dati. Okay, so now, gamit ulit tayo ng interaction diagrams, no? So, for our interaction diagram, ang kailangan ulit nating malaman, teka, isulat ko na lang dito. Okay, so for interaction diagram, so we must solve for these particular values. So we must solve for our gamma. We must also solve for our E divided by H. And we must solve for our rho G, or the still ratio of the gross area. So, yan tatlong yan lang naman yung kailangan natin malaman para makapag-interaction diagram tayo. Okay, so for our gamma, so erase ko muna itong tatlo. For our gamma, this is basically equal to gamma H divided by H. So, ito guys, yung H natin na to, dapat yan yung dimension that is parallel to your eccentricity. Ngayon nga, di ba, ang kinukuha nating eccentricity is to build this location. So, ito na ngayon yung eccentricity na kinoconsider natin kasi nasolve naman na natin ito last time. So, nasolve na natin yan. And kung ayaw nyo maniwala, isolve nyo na lang ulit. Pares dapat tayo ng sagot approximately. Okay. So, anyway. So, if that is to be our eccentricity, our gamma H, teka, yung gamma H pala natin, no? So, ito. Gamma H is to be equal to your H minus your effective concrete cover. So, with that, so dito, yung gamma H natin is to be our H. So, nakalagay dito ang H daw natin 650. Pero hindi na ito yung gagamitin natin H. Ang H natin, ulitin ko lang, is to be the dimension of your column that is to be parallel to your eccentricity. So, this time, 400 naman gagamitin natin. So, 400 minus, so it is to be the effective concrete cover. So, when I say effective, that should be measured from the extreme extreme concrete fiber up until the centroid of your steel. So, given naman dito, 65 daw. So, minus 65. So, ayan. Minus 65 ulit kasi two sides nga, no? So, bawas natin yan. Bawas natin yan. Okay, so with that, this is now to be equal to, so looking at the calculator, so 400 minus 65 minus 65, 270. So, 270 mm. Okay, so for your gamma, so gamma is to be equal to gamma H divided by H. So that this is now to be equal to 270 divided by 400. So getting our answer here. So divide this by 400. So this is now to be 67.5. 0.675. Okay, so ayan na ngayon yung gamma natin. So lagay ko lang dito. Okay, so what's next? So ito yung gamma natin. So solve din natin yung rho G. Yung rho G natin, area of the steel lang yan divided by gross sectional area. So hindi ko na i-substitute dyan sa board natin. Rekta na natin sa calculator. So, for the area of the steel, so hindi ko na naman naisulat dito. Ang nasa problem natin, 28 mm rebars ginamit. And we have here 12 pieces of rebars kung bibilangin nyo man. So, 12 times pi over 4 times 28 squared divided by, so ano ba yung cross-sectional area natin? That is to be 400 times 650. So, 400 times 650. Okay, so our answer here is to be 0.0284. So unitless kasi nga ratio siya. Okay, so as for our E over H, that is basically equal to, so ang E natin is of course our eccentricity. So yung 200 divided by H. Ano ba yung H natin? That should be this. So yun yung dimension ulit ng column natin along that direction. So 400. So 200 by 400, kahit di pa natin i-calculate yan, 0.5 yan. Okay, so we would be using these parameters for us to solve for PN, or yes, for us to solve for PN using our interaction diagram. Okay, so first, 0.675. So ngayon, hahanapin natin yung tawag dito yung interaction diagram na merong gamma na 0.675. However, guys, no, wala talagang ganong table. So with that, since that is to be 0.675, ang gagawin ko ngayon is that I will be using the interaction diagram that has a gamma of 0.7, then 0.6. Tapos mag-interpolate na lang ako ng value. Okay, so what I mean here is that, so ito yung sigma tuloy. Ito yung gamma for 0.6, and this is now to be the interaction diagram for gamma equal to 0.7. So, dahil ang gamma natin is to be equal to 0.675, it is to be in between this and this. So, ang gagawin ko, kunin ko yung value dito, kunin ko yung value dito, kunin ko yung value dito, then, what you call that, and then, ayun, i-interpolate ko. Okay, so, what is to be my Kn in this location? So, ito yung Kn natin. So, ang gawin natin, so, nakalimutan ko yung E over H natin. Yung E over H natin is to be, so, 0.5. So, with that, guys, so, etong line na to, mga nakadiagonal, ito yung mga E over H. So, exactly 0.5 daw siya. So, itong line na to yung gagamitin natin. So, yan. Teka, medyo liitan konti. So, we would be making use of this line. And, of course, this line. So, dalawa yan. So, yan yung 0.5. Okay, so what else? So, for our value for our rho g, so our rho g is to be 0.0284. So, balik na naman tayo. So, napakadali nito. So, ito daw yung curve. So, mag-blue line muna ako. So, ito daw yung curve for rho g equal to 0.01. This is to be the curve for rho g equal to 0.02. This is to be the rho g for 0.03, and etc. However, since our rho g is once again equal to 0.028, so it is in between 0.02 and 0.03. So, dapat meron pa tayong isang line dito sa gitna nila. So, pangit lang ng drawing ko. Pero kung ganyan din lang, ang gagawin ko na lang, I will just be getting the intersection of 0.02 here. So, itong part na to. Then 0.03 at this part. So, yung part na yan. And I will be getting 80% of it. So, I'm assuming that it is to be this line. So, ayun, ulitin ko lang. One limitation is that nag-approximate tayo dito sa graphical method. So, I am assuming that my 0.08 is to be located here. Teka, alisin ko na yan. So, I am assuming that my 0.08 is to be located here. Then, ang value natin ngayon ng Kn, so ano ba to? Teka, naduduling ako. So, ano ba to? So, if this is to be 0.3, this is to be 0.32, this is to be 0.34, this is to be 0.36. So, with that, ang Kn natin dito, 0.36. So, dyan. So, what about for this graph? So, ganun din. Nasa yung 0.02 nandito. Yung 0.03 nandito. So, I am assuming that the approximate location of our rho g 0.028 is to be here. So, dito banda. Tigang kapal ng mukha ko. Ay, nung ano ko na kapal ng drawing ko. So, ito. So, I am assuming that it is to be exactly 0.4. So, 0.4 naman. So, with that, Kn, So, with that, Kn is now to be equal to 0.4. So, ayan. So, anong gagawin natin dyan? So, next slide na naman tayo. So, for gamma, and this is now to be for your Kn. So, for gamma equal to 0.6, then ito, ay, 0.6 ba? O, tama. 0.6, this is to be 0.7, then ito yung hinahanap natin, 0.675. So, dito naman, sa Kn natin, ang na-solve natin dyan, 0.36. So, 0.36. Then, dito, na-solve natin dyan, 0.4. So, 0.4. Okay, so now, ang hanapin natin is to be this value. So, let's say that that is to be Kn, let's say, 0.65. I mean, 0.675. Okay, so, interpolate, or pwedeng ratio in proportion. Basta, alam nyo na yan. So, with that, what I would be doing is that I would be getting this fraction. So, 0.7 minus 0.6 divided by, so this one, or the difference of this, so that is to be 0.4 minus 0.36. And this is to be equal to, let's have this equation. Or pwede ding ito, kayo bahala. Pero mas gusto ko ata ito. Okay, so with that, this is now to be equal to, so 0.675, oops, sorry, 675 minus 0.6 divided by, so ito, so Kn, so hindi ko na isusulat yung subscript niya, minus 0.36. So shift solve ko na lang para mabilis, gets nyo naman na yan. So 0.7 minus 0.6 divided by 0.4 minus 0.36, this is now to be equal to 0.675 minus 0.6 divided by alpha x minus 0.36. So, tama ba? Okay, so shift solve, and my answer here is to be, ang tagal, 0.39. So, Kn is now to be equal to, teka, ulitin natin para mas maayos. So, Kn is now to be equal to 0.39. So, this is now to be our answer for Kn for uniaxial bending along the y direction, and it is about the x-axis. Okay. So, for your PNXO, so dito ko nalagay. So, for your PNXO, using once again this value, so KNXO is to be equal to 0.39. Then, yung equation natin ng Kn is to be Kn is equal to Pn over F prime CAG. So, this is to be PNXO divided by FC prime AG. So, substituting known values, so F prime C is to be equal to 27.58 times the cross-sectional area, and that is to be 400 by 650. Tama ba? Check lang. So, 400, 650, tapos 27.58. Okay, so ayan. Solving for PNXO, so your PNXO is now to be equal to, so that is now to be equal to 0.39 times 27.58 times 400 times 650. So, tama. Okay, and I will be dividing this by 1,000 kasi in terms of newtons tong na-answer ko. I mean, tong answer ko. So, convert ko ng kilonewtons. So, that is now to be equal to 2796.612 kilonewtons. Okay, so with that, sulat ko na dito. Okay. So, ngayon meron na tayong PNXO, meron na din tayong PNYO, but what about for PO? So, for your PO, you can either use the interaction diagram, pero yung sa interaction diagram natin, ang kukunin nyo, E over H is equal to 0 kasi nga dapat concentric, dapat walang eccentricity. So, kunin nyo yung value na to. Kung saan man yung rho g. So, I think banda rito siya. Pero better yet, since napakadali namang mag-solve ng PO, isolve na lang natin yung PO using analytical method or yung formula. So, yung PO natin is to be equal to, so 0.85. So, ulitin ko lang guys, yung PO natin is to be the force of a concentrically loaded column or the capacity of the concentrically loaded column. So ito, 0.85 times FC prime times area gross minus area steel plus Fy times area steel. So substituting known values, 0.85 times 27.58 times gross sectional area, that is to be 400 times 650 minus AST. Teka, solve ko na nga lang. So yung AST natin is to be pi over 4 times 28 squared times 12. So ito yung, kasi 12 pieces ng rebars. So 2352 pi. So 2352 pi plus Fy, and our Fy is to be 413.7 times 2352 pi. Okay, so solving for our PO, this is now to be equal to, so 0.85 times 27.58 times 400 times 650 minus 2352 times pi. Close natin yan. Plus 413.7 times 2352 pi. So our PO is now to be equal to 8978799. Divide ko by 1,000 just for me to convert it into kilonewtons. So my answer here is to be 8978.8. Nalalagay ko 0.8 or 799. So 799 kilonewtons. Okay, so check ko nga lang. Baka naman mali mamaya. 0.85, 27.58. 400 by 650 minus 2352 pi plus 413.7. 2352 pi. Teka. Okay, so ayan. So now that we already know all of the values here, substitute na natin. So with that, for our value for 1 over Pn, so 1 over Pn, this is now to be equal to, so 1 divided by Pnxo, 1 divided by 3585.4 kilonewtons plus 1 over 2796.612 kilonewtons minus 1 divided by 8978.799 kilonewtons. Okay, so with that, our value for our Pn is now to be equal to, so ngayon solve na natin. So 1 divided by 3585.4 plus 1 divided by 2796.612 minus 1 divided by 8978.799. So ngayon, teka, i-shift solve ko na lang. So 1 divided by alpha x. So our answer here is to be 1904.359 kilonewtons. So this is now to be our final answer. Okay, so i-confirm ko lang, instead of us using shift solve, so kunin ko yung answer neto, then I would just be inversing it. So yan, pares lang. So 1904.359 kilonewtons. So this is to be via reciprocal method. So what about for the other one? So yung isa kasi load contour method, this time we would be using their moments instead of our Pn. So yung moment natin, if this is now to be our, let's say our interaction diagram, kung nakikita nyo dito sa baba guys, so isulat ko lang kapag di nyo nakikita. So dyan kasi sa baba, teka, nasan ba yan? So ito sa baba na to, ang nakasulat dyan, Rn is equal to Pne divided by F prime C A G H times E. So Pne pala to. So ayan. So guys, itong Pne, yan yung moment. So force times eccentricity, moment na yan. So pwede mong gamitin itong interaction value dito, or if you have already solved for this, so di ba ito Kn, is equal to Pn divided by F prime C times Ag. So, pag nasolve nyo na ng Pn na yan, alam nyo naman yung E, edi multiply nyo ng E, edi yan na yung moment. So, napakadali niyan. Okay, so let us now proceed here. Saan tayo magpa-proceed? So, okay. So, I will just be copying this, guys. So, copy ko lang sandali. Para... Ayan. Okay, so ito naman. So, same naman for interaction diagram. Yan pa rin. Pero, ang kailangan natin ngayon, instead of us having your PNYO, PNXO, and PO, we must have, of course, our MNX. Teka, copy ko na lang para pakita ko doon. For a moment. So, ito naman yung gagamitin natin, guys. So, ito. Okay, so as said here, your MNX at the top is to be the moment about the x-axis. So, meaning, if it is moment about the x-axis, kung ito yung x-axis natin, para magkaroon dyan ng moment, you must have your P and your eccentricity that is perpendicular to that axis. So, meaning, that is to be Pn times EY. So, itong Pn na to, guys, is to be the strength of biaxial member already. So, yan yung nominal load na pwede niyang makakuha. And as for your MNY, so if this is now to be your y-axis, so for you to have a moment about that point, dapat yung eccentricity mo is EX. So, okay, malito. Pag sinabing MNY, so pag sinabing MNY, EX dapat yung eccentricity mo. So, ayun. Okay, so with that, guys, so let us rewrite this equation here. So, this is now to be equal to Pn EY raised to alpha 1 divided by, quantity pala dapat to. Divided by Mn XO raised to alpha 1 plus Pn EX divided by MNYO raised to alpha 2. This is now to be equal to 1.0. So guys, ito pala, the range of your alpha 1 and your alpha 2, the ranges from 1.15 up until 1.55 for lateral tied column. So ito, laterally tied siya. And with that, guys, it is conservative for us to use 1.15 if it is not given in the problem. And since it is not given in the problem, then let us use 1.15. So with that, ba't ko ni-raise? So with that, guys, ito yung gagamitin nating alpha 1 and alpha 2. So itong EX na to, given yan sa problem. Itong EY na to, given yan sa problem. But what about for our MNXO and for our MNYO? Okay, so for our MNYO, so ito yung moment about your y-axis. So basically, yan yung moment na kapag yung H mo is to be 650 and your eccentricity is to be, ito, 312. So it is to be given by this interaction diagram. So ito yung sinolve natin the last time. So guys, if you would now be projecting this downwards, so ito. So pag project ko yan downwards, teka. Ang answer dyan, so ito 0.24 ngayon yung makukuha kong value dito. So 0.24 dito. Okay, so 0.24. So Rn is to be equal to 0.24. Pero sabi nga niya, di ba ang Rn, that is now to be equal to, so Pne divided by F prime C times Ag times H. Okay, so substituting known values, so ito 0.24. Itong Pne natin, so ito palitan na lang natin to, instead of Pne, gawin natin yung Mn. So with that, Mn na to, divided by F prime C, that is to be 27.58, times cross-sectional area of 400 times 650, times H, and ang H natin dito is 650 also, kasi yung H natin is to be this dimension. So, itong dimension na to kasi yung bending niya about this axis. So, ito yung eccentricity kasi. Okay, so, solving for that, nawala. So, solving for that, so 0.24 times 27.58 times 400 times 650 times 650, and that would give us an answer of 1118,644,800 newtons. Newton millimeter. So for me to convert it to kilonewton meters, I would be dividing this by 10 raised to 6. So conversion lang. So with that, guys, ang answer natin dito is 1118.6448 kilonewton meter. So, isang way yon para malaman mo yung value mo ng Mn. So, another way is by multiplying your Pn by E. So, itong Pn natin na yan, nasolve na natin yan before, and that is now to be equal to, so, 3585400 newtons. So, nasolve na natin yan before. And kung ayaw nyo maniwala, pwede nyo namang i-resolve dito. So, sige, resolve natin yan. No? So, 0.5 times what is to be our f prime c, that is now to be equal to 27.58 times ag, and ang ag natin is to be 400 times 650. Okay, so 3585400. So yan yung Pn. Ngayon, para maging moment siya, di ba ang moment natin Pn times E? So yun yung Mn natin. So Pn times E, so ang eccentricity natin by the problem is 312. So given to sa problem. So with that, so same na sila ng answer ngayon. So ngayon, divide natin by 10 raised to 6 para maging kilonewton meter lang. So ayan, kung makita nyo, 118,644,8 kilonewton meter. So yan yung gagamitin natin ngayong MNY. So yan. Okay. So with that, so teka, i-copy ko lang to our next slide. So, ayan. So, for our MNYO, that is basically 1118.6448 kilonewton meter. So, ito, kilonewton meter yan. So, guys, huwag niyong kakalimutan yung units nyo. If for example, gusto nyo Newton millimeter, pwede din naman, basta dapat consistent. Okay, so for our MNXO, so guys, ganun na din lang gawin ko. No? So nasolve na din lang naman natin yan kanina. So your MNXO is ito. PNXO times our lever arm. So teka, kopyahin ko lang. Baka makalimutan ko eh. So ito, that is to be PNXO times lever arms, and our lever arm is to be equal to, so lever arm natin 200 mm. So times 200 mm. Pero guys, tignan nyo to, no? Naka-kilonewtons to, tas naka-millimeters to. So with that, guys, convert ko na lang to ngayon ng meters. So guys, yun, dapat alam nyo yung mga units nyo. So with that, this is now to be equal to 0.2 meters. So 200 mm is to be equal to 0.2 meters. So with such, this is now to be equal to, so 2796.612 times 0.2, so 559.3224 kilonewton meter. So ito nga yung sagot natin for MNXO. So we already have MNXO, MNYO. And itong alpha 1 and alpha 2 natin, let us assume it to be 1.15. Okay, so with such, we can now solve for it. So guys, malamang magkaiba yung answer dito, pati yung sa isang method, no? So ayun, so for your Pn EY, so Pn times EY, so our EY is to be 200 mm. 200 mm. However, guys, if this is to be in terms of kilonewton meter, it is better na gawin ko na lang tong meters na lang. Pero pwede din naman gamitin yung 200 mm to, pero dapat yung nasa denominator nyo must be in terms of Newton millimeter. So dapat consistent lang yung units natin. So if you would be doing it that way, dapat same yung answer nyo. Okay. So divided by, so what is to be MNXO? 559.3224. So this is to be raised to 1.15. So plus So Pn, what is to be our eccentricity x? So Pn Ex is to be equal to, so our Ex is to be 312 mm. So 312 mm, so converting it into meters, that is to be 0.312. So ulitin ko lang, pwede nyo naman gamitin yung 312 mm dito as long as the moment that you will be putting here is to be in terms of Newton millimeter. Pero dahil naka-kilonewton meter siya dito, edi ito yung gagamitin, which is to be in terms of meters. So, unit consistency. So, 1118.6448 kilonewton meter raised to 1.15, and this should be equal to 1. So, yun, kanya-kanyang solve. So, in my case, shift solve na naman ako. So, with that, so, alpha x times 0.2 divided by 559.3224. This should be raised to 1.15. So, plus alpha x times 0.312 divided by 1118.6448 raised to 1, oops, sorry, mali. Raised to 1.15, and this is to be equal to 1. So, shift solve ko lang. And with that, ang answer daw niya dito, if you would be using this method, our Pn is to be equal to 1717.82 kilonewton. Okay, so guys, kapag ang ginamit nyo dito, millimeter, then ang ginamit nyo dito, Newton millimeters, ang answer na maipapalabas nyo dito is to be in terms of newtons. So, yun, do not forget about the units. So, if you would be comparing it, no? So, let's compare this answer. Ito yung answer natin using, anong tawag dito sa method na to? Load contour. So, this is to be our answer using load contour. And this is to be our answer for our reciprocal method. So, magkaiba talaga sila, guys. So, magkakaiba kasi ng mga values, especially in this part. Meron tayong value ng alpha and inassume lang natin yan actually. So, ayun. So, that is how simple biaxial bending is. So, napakadali ng biaxial bending as long as you know how to solve for uniaxial bending. Okay guys, no? So, as you can see, these are to be the values for your Pn. So, sa totoo lang, hindi pa pala tapos to. So, ang tanong pala sa problem is to be the design axial strength. So, for the design axial strength, multiply mo ngayon yung phi mo dito kasi nga 'di ba yung design axial strength natin is to be in terms of Pn. So, ito yung para sa reciprocal method. So, ito yung para sa reciprocal method. Tapos, para sa tawag dito. Saan yung isa? So, for your load contour method, it would be this one. Okay, so ito yung, parehas. Hindi ko nakopya. Teka. So, ito yung sa load contour method natin. Naiwan. Teka. So, ayan. So, ulitin ko lang. Ito yung sa reciprocal. Teka. So, ito yung sa reciprocal. Ito yung sa load contour. Okay, so for your reciprocal, phi Pn. So our phi for laterally tied columns are to be is to be 0.65. So with that, our phi Pn is now to be equal to once again, phi times 1904.359 kilonewtons. So with that, our phi Pn is now to be equal to, so I'm looking at the calculator, so 1904.359 times 0.65. So 1237.8335 kilonewtons. So ito na yung phi Pn natin na bago. And for our VPN here, so same old, our fee is also to be equal to 0.65. So with that, our VPN is now to be equal to, so 1717.82 times 0.65, nawala ulit. So 1717.82 times 0.65. So this is now to be equal to 1116.583 kilo Newton. So this is to be our answer. So kulang kasi ito. Nominal lang to ang tanong design. So ito yung sa design, actual strength ng biaxial.